Bismillahirrahmanirrahim. How are you, students? Today we will study lecture number 8, same chapter, sound. Today we will finish this chapter. Today topic is reflection of sound. Chapter is sound. Reflection of sound. The bouncing back up sound from rough surfaces or smooth surfaces is called reflection of sound. When sound incidents on the surface of another medium, it bounces back into the first medium. This phenomena is called echo or reflection of sound. So, the sensation of sound persists in our brain for about zero point 0.1 second. 0.1 second. To hear a clear sound echo, the time interval between our sound and the reflected sound must be at least this one. So if you produce sound in a hall in which there is no absorbent, plastic, clothes, wood, any material which can absorb sound, these are not present. Empty room. You will hear the same sound after some interval of time. You will hear your sound back. This is called echo. For hearing distinct echoes, the minimum distance of the obstacle from the source of sound must be half of distance. If a sound is activated in a room, sound travels readily in all directions. Waves travel in all directions. As the sound waves encounter obstacles or surfaces, such as walls, their direction of travel is changed. They are reflected. The diagram shows the reflection of waves from a sound source from a rigid plane wall surfaces. So the given diagram represents reflection of sound. Speed of sound. Waves can be transmitted by any medium containing particles that can vibrate. They cannot pass through a cube. The nature of the medium will affect the speed of sound, because in solid, sound travels faster as compared to air. Why the sound travels faster in solid as compared to air? Because in solid molecules are closely packed. Molecules or atoms are close to each other. So more will be the speed, more will be the velocity. The speed of sound in air is 348 in meter per second. 348 meter per second. The speed of sound in air, 348 meter per second. It's a mistake. It's not 8, it's 343 at 21 degrees Celsius in your book. I don't agree. Okay, but in your book it is written 343, so you should memorize at 21 degrees Celsius. So follow your book. The speed of varies with temperature and humidity. The speed of sound in solid and liquid is faster than in air. Following relation can be used to find the speed of sound. To me, it's 330 meter per second at 27 degrees Celsius. So it must be less than 330 to my knowledge. You can search it on Google. Where V represents velocity, F represents frequency, and lambda represents wavelength. Where V is the speed, F is the frequency, and lambda is the wavelength of sound waves used. Calculate the frequency of a sound wave of speed 3 meter per second. This is speed, this is wavelength. So speed, wavelength, V is equal to F lambda. Calculate. It's very easy. Importance of acoustics. The technique. Acoustics is the technique or method used to absorb undesirable sound by soft and porous surfaces. Porous surfaces is called acoustic protection. To reduce the undesirable effects, to eliminate the undesirable sound or unwanted sounds. So the technique or method to absorb undesirable sounds with the help of plastic, clothes, wood, different types of material, you reduce the jarring effect of sound. Acoustic is the branch of physics which deal with the generation, propagation, reception, and analysis of sound waves. In acoustics, we study how to generate, how sound is generated, how it will propagate, how it can produce the perception of hearing, and analysis of different properties of sound. Generally, the ceiling of lectures halls, conference halls, and theater halls, theater halls are curved so that the sound after reflection may reach all the corners of the hall. Sometimes curved surfaces, board, are placed behind the stage so that sound after reflection distributed evenly across the hall. So if you look to the given diagram, you can see this, you can see this, you can see this, you can see this. This reduces the jarring effect. Here you can see it reduces the jarring effect. This is called acoustics. Reverberation. This prolongation of sound in a hall, even though the source of sound is cut off, is called reverberation. Sound produced in a hall undergoes multiple reflections from the walls, floors, and ceiling before it comes inaudible. Multiple reflection of sound is called reverberation. Reverberation time must be less than 0.1 second. The time taken by the sound in a room to fall from its average intensity to inaudibility level is called the reverberation time of this room. Reverberation time is defined as the time during which the sound energy density falls from its steady state. The time during which the audible sound will become inaudible is called reverberation. To me, reflection of reverberation is the reflection from nearby wall, and this is called, and reflection from far places is called echo. This produce echo because sound goes reflected, it is called echo. You can see, look at the diagram, this is echo. Here the sound is reflected from nearby wall, so you will see here it's reverberation. It's reverberation. Look again, see the first diagram, look at this is reverberation. So nearby wall. So note the time, note this time travel to this distance, 0.07 second. It's 0 point for only one vibration. I will clear the lines only for this. Note the time, it's less than 0.1 second. less than 0.1 second. Uh, Note all the vibration. The total time is 0.36 second. 1, 2, 3, 4, 5. 5 half vibration. So 36 divided by 5, it's near about 0.07 second. 0.07 second. Note again from the beginning. We will start from the beginning. Now begin. 1, 2, 3, 4, 5. For 5 half vibration, the time is 0.36 second. So divide, you will get the answer. Audible frequency range. Audible frequency range is characterized as a periodic vibration whose frequency is audible to the average human. The sound which is audible to us is called audible sound. Audible frequency range is the sound whose frequency is less is greater or equal to 20 hertz and less or equal to 20,000 hertz is called audible range. If the frequency of sound is greater than 20 hertz or it is equal to 20 hertz and your ear is in normal working condition, you will hear the sound. If it is more than 20 hertz, you will hear. But if it is less than 20,000 hertz, you will hear. If more than 20,000 hertz, you will not hear. So audible frequency range is the range of frequencies whose frequency is greater than 20 and less than 20 hertz are equal to these values. It is called audible frequency range. It changes with change in age, change with the condition of the air. All telephone circuits operates with AF signals in a restricted range of approximately 200 Hz to 300 Hz. Audio frequency. AF means audio frequency. Different people have different range of audibility. It also decreases with age. Now, ultrasound. Sound of frequency higher than 20,000 Hz, which are inaudible to normal human ear, are called ultrasound or ultrasonic. Ultrasonic waves are the waves whose frequency is greater than 20,000 Hz. Used for different purposes. Ultrasonic is used. Ultrasonic is sound waves with frequency higher than upper audible limit of human hearing. Ultrasound is not different from normal audible sound in its physical properties, except that human humans cannot hear it because not an audible range. Different animals have different species have different range. Ultrasound devices operate with frequencies from 20 kilohertz up to several gigahertz. Use of ultrasonic waves. Ultrasonic waves carries more energy and higher frequency than audible frequency range, audible sounds. Therefore, according to wave equation V is equal to F lambda, the wavelength of ultrasonic waves is very small and is very useful for detecting very small objects. Use of ultrasonic waves in medical. In medical field, ultrasonic waves are used to diagnose and treat different diseases. To diagnose different diseases, ultrasonic waves are made to enter human body through transmitter. These waves are reflected differently by different organs, tissues, or tumors. The reflected waves are then amplified to form an image of the internal organ of the body on the screen. Such as image helps in detecting the defect in these organs. Powerful ultrasonic waves is now being used to remove blood clots formed in the arteries. Ultrasonic can also be used to get the picture of thyroid glands for diagnosis purposes. In technical field, ultrasonic are utilized in technical field. Ultrasonic is used to locate underwater depths, used to calculate the depth of ocean. Its locating is used for locating objects lying deep on the sea floor, etc. The technique is called sonar, sound navigation and ranging. Sonar. The sound waves are sent from a transmitter and receivers collect the reflected sound. The time lapse is calculated knowing the speed of sound in water. The distance from the ocean surface can be estimated. Sonar ranging is also used to see the shape and size of the objects. Cracks can be detected with the help of ultrasonic waves. Cracks appear in the interior of a moving parts of high-speed heavy machine, such as turbine engine of ships and aeroplane, due to excessive use. These cracks are not visible from outside, but they can be very dangerous. Such cracks can be detected by ultrasonic waves. A powerful beam of ultrasonic wave is meant to pass through these defective parts. While passing, these waves are reflected by the surface of these cracks and flaws. The comparisons of the ultrasonic waves reflected from cracks and from the surface of these parts can give clues of the existence of the cracks. Germs and bacteria in liquid can also be destroyed by using high-intensity ultrasonic waves. This is what is written in your book. To me, it is used to calculate the abnormality of child before birth. It is used to calculate the depth of ocean. It is used for the scaling of teeth due to high frequency. Why ultrasonic waves are used for the scaling of teeth? Due to high frequency, it is used for the scaling of teeth. Calculate cracks in the machinery, cracks in the pipes. So ultrasonic waves are used to kill germs and bacteria. You can use for many other purposes also. So thank you, students. This chapter is finished. If anything is left, you can ask me in Zoom class, or if you want that I will explain anything which is in this chapter for you people, you can WhatsApp me your queries. I will give you reply, and I will try to overcome those weaknesses and will complete anything which is left. Just let me know through my personal WhatsApp. Thank you, students. Allah Hafiz.